sending in some pictures. This is the Robotics Club of the Palouse. They are a combination university team from Washington and Moscow, Idaho. We've been really happy to have them out here this year. They built a really nice hardware platform, and it's going to serve them in good stead for the next few years as they get their software working and participate in the competition. We haven't been having a lot of questions get sent in yet. So anyone who's out there who has a technical question, wants to have answered by the guest panelists, or alternatively, Daryl and I can do the best of our ability as well. Please send them in. We have a few more people who are on site here who have been sending some pictures. Here is the Mechatronics team, which is a local team from San Diego that has put a big team together, done a lot of work. Here they are, showing their team pride with their sub hanging there in the background. It's been great to have them here on the site too, and I think they're pretty happy with how they've done in this competition. So up next, the reigning champions, Cornell University. Daryl, we're expecting some great things from Cornell. They also achieved an absolutely phenomenal number of points in the semifinals session, so we could see some very, very exciting things here ahead of us in the competition. So while we reposition for Cornell to get in the water and we invite one of their representatives to come up here, let's cue Cornell's team intro video.
CUAUV is an entirely undergraduate-run student project team consisting of 40 students representing 10 majors and 3 colleges at Cornell University. We offer a unique opportunity for students to gain experience working in a cross-disciplinary project environment, exploring cutting-edge AUV technology. We are separated into 4 sub-teams: mechanical, electrical, software, and business.
Our mechanical team designs and manufactures various enclosures, structures, and actuators for the vehicle. We use the latest technologies to optimize the vehicle, creating a robust platform for the task at hand. Our electrical team focuses on designing, populating, and testing the custom circuitry in our vehicle, which handles power management, serial communication, as well as acoustic signal processing.
Our software team is responsible for programming the vehicle, including high-level mission logic, vision processing, and precise vehicle control. Software also develops offline utilities, such as tools for simulation and vision performance evaluation.
And finally, our business team is responsible for organizing outreach events with Boy Scouts and Girl Scouts, local schools and our community, contacting our sponsors, and promoting our team.
After spending 5 months designing, 4 months manufacturing, and 3 months testing, we are more than ready for RoboSub. We would like to present CUAUV's newest vehicle, Gemini.
With a lower, sleeker, and more hydrodynamic profile than ever before, Gemini represents a breakthrough in AUV technology. 8 upgraded thrusters provide more than 2,000 metric watts of power and 6 degrees of freedom control. A hinged rack for our custom boards makes maintenance easy, and a fully integrated backplane enables plug-and-play capability. A suite of new features makes Gemini our most mission-capable vehicle to date.
We are actively testing and looking forward to seeing everyone in San Diego.
Awesome. Well, we're super excited to see what Cornell's going to do in the water in this final session. And joining us to help us make sense of its robot antics is Mark Lee. Mark, thank you so much for joining us up here.
It's our pleasure.
So, what might we see in the water when Gemini gets its feet wet, so to speak?
To be honest, it's actually a question for me to ask myself too. Just because we actually scrapped together the mission optimizer a couple of weeks ago before coming here. And we're trying to be as hands-off as possible because, I mean, the whole overall challenge for this competition is autonomy. And strictly sticking to that, we want the vehicle, our Gemini, to be making an active and intelligent decision on its own while it's in water. So we actually haven't had too much testing time in Transdeck as well, so we'll see how it goes.
Wow, we might see all kinds of things.
I'm excited and intrigued now.
Yes, indeed. We'll talk a little bit more about some of the things we might see, I guess, once we get the run started. There it is over at the dock. Let's do a 5 count. 5, 4, 3, 2, 1. Run start. And the diver there putting his hands in the air, showing no more human intervention while this robot does its thing. First for the gate. Are you guys also open looping it through the gate, or do you have feedback control?
We're also open loop. So that's why we have to set our vehicle right at the corner and point it straight to the middle of the gate. Sometimes if we are very close to not making it to the gate, the vehicle will adjust itself. But most of the times, we want to shave off as much time as possible and stick to most of the points and time to hydrophones.
Well, that was also a very quick run through the gate, and you could see that the robot knew that it was through the gate. Bam! There's a red buoy bump. All right. More points on the board in the first minute of the run. That's absolutely fantastic. But yeah, you could see it stop. It knew it had passed through the gate and switched to a different mode.
Right.
Skipping the lit buoy?
We are passing buoy now, and then we'll be following that pipe. And then the pipe will hopefully lead us to the wired task. And we'll be circumnavigating the pipe, which will happen maybe within 5 to 10 seconds from now. Maybe I was a little too short on the timing.
That's all right. I'm sure it'll feel like that to us, or maybe a lot longer. The maneuvering task has to pass, the sub has to pass through the virtual square defined by the sides and the middle thing, and here we're seeing the orbit.
Nice.
Very, very nice. Going straight around in a perfect circle there. That is absolutely lovely. More points on the board for Cornell.
Very nice.
Congratulations.
And then afterwards, we will be tracking this pipe just for localization, and then we'll be hopefully heading over closer to the hydrophones now.
Will there be a point at which the sub switches into a purely listening mode and goes for those hydrophones, or is it sort of a smooth transition?
So we found out that during our past practice runs, there is more of an optimal location for us to record pingers or pinger listenings, and then that will be somewhere very close to the a little bit of a center towards the 2 octagons. And once Gemini gets very close to the octagons, you will be able to see that the vehicle will stop and just listen for pings and then make its decision to go on from there.
Moving with purpose now towards the octagons. From this viewpoint, looks like it's kind of going between them.
Right between them is where we want to acquire the signals.
All right. We possibly could have had a pinger switch. We don't know which one is the correct octagon now, but it's probably safe to say that whichever the sub goes for is going to be the correct one, because it's the only one pinging.
Just hoping Gemini will be feeling a little bit hungry today and go for some cheese.
Yeah,
Thank you.
Certainly wouldn't recommend that humans consume green cheese necessarily, but for robots, it's fine. So I'm just trying to get a vantage point here of where it is from where I'm looking. Looks about half in and out of the far octagon, but the diver is giving an indication that it's oriented towards the other and moving over closer to us.
It's actually not going to be surfacing in the correct octagon until it has picked up the Mars rock or cheese.
Once again, that's a good optimization to make because it's going to be there anyway,
Right.
depositing off the rock or the cheese, and so it might as well save a little of that precious runtime. Now here we get a good look at the way that the Cornell submarine is arranged in terms of its grabbers. It's actually got 3 grabbers, isn't that right, Mark? Tell us a little bit about that design decision. Oh, so there goes a Mars rock.
There's the first Mars rock. So there was actually been a significant change in our grabber design. So originally, if you actually look at the rendering in our banners in front of our tent, you can see that the rendering only has 2 grabbers and it's very close to the actual center of the vehicle. But then that actually proposed a lot of challenges, and one of the challenges was that it would be interfering, whenever we grab Mars rock or cheese, it would be interfering with the beacons from the DVL, and we can't have that because whenever we grab an element, it would be interfering and we wouldn't be able to accurately navigate. So with that...
Oh, that looks like a successful grab to me, another moon rock. Yes.
That's amazing.
Two rocks at once, and then the third grabber mounted 90 degrees orthogonal to those two on the... is it the rear?
It's the aft, yeah, it's the rear.
The aft end of Gemini, and so that'll be coming in to pick up a third one.
What always, sorry.
Go ahead.
What always makes me laugh, though, is whenever I see Gemini picking up its Mars rock or cheese, especially with the aft grabber, you'll be able to see that it kind of sits on its butt, and then it'll be kind of a better grab for the Mars rock or cheese. So hopefully that's what we'll be able to win this briefly as we approach to
There we go. That looks like a positive grab to me, and
there we
it's
go.
a piece of cheese. But we've lost the rock. Oh no!
Maybe we're getting a little too greedy there.
Well, a rock and a cheese is not to be sneezed at with 19 minutes left in the run, that's for sure. I didn't see every single run that you guys did. Was there any time earlier in the competition that you successfully picked up 3 at once?
Yes, we have. But just as you have seen now, we do have some issues with our grabbers, and just because that's something that we have implemented a couple of weeks ago, and haven't had too much time actually to test it in Transdeck.
Yeah, well, these, as we mentioned earlier during Florida's run, these moon rocks and cheeses are actually quite heavy, and they could cause significant bending of the plastic grabber.
Right. And that's actually one of the reasons why we actually tilt, whether it's toward the starboard or port side. It's because if you just go straight down, there's also a chance that we might be able to crush the connects that we already acquired. So in order to reduce or minimize the chance of...
Yep, so that's where it would have dropped a Mars rock if it was still out, and there's a successful drop of a Mars rock. And that is, we're receiving confirmation that is the correct octagon. However, a non-sorting of the cheese and the rock, so it's possible that it thought that cheese was a rock?
I believe so. This is actually, to be honest, my first time where I've seen failure in terms of the sorting. Even in Transdeck, I think we've always successfully sorted Mars rocks from cheese.
Well, there's a couple of ways that could have happened. It either could have mistaken green for red down there at the bottom of the pool, or it could have, some of those were kind of close together. It could have gone to grab a Mars rock and accidentally grabbed the cheese.
Especially with the outdoor pool right now, like anything could happen in terms of the vision, whether it's distinguishing between the red and green.
Yeah, I would challenge any human looking at from here to say that they could 100% reliably tell red from green on the bottom of the pool. They both look pretty dark. Leaning down for a grab and a successful cheese pickup.
So our strategy is actually, for the first 3 grabs, we solely go for just the Mars rock. And in the best case scenario, we would be able to acquire all 3 Mars rocks. And then we drop them off, and then we come back for second rounds. And then that's when we really, dig ourselves into getting this cheese.
So tell me about object collection end game, because the robot now thinks that it's picked up more and different objects than it actually did. Does it keep coming back until it sees that there are no objects, or does it just keep a count?
It does, actually. I think we set a hard deadline in terms of 5...
Successful cheese pickup.
It's always good to see. But yes, Josh, to answer your question, I think we actually do have a hard count in terms of how many times Gemini will come back for more. Because overeating is always too bad, as my mom always tell me.
Indeed.
So after 5 times or so, Gemini will actually forego completing the hydrophone's task and go for the next priority, which is going to be bins.
Well, it's definitely important to approach all things in moderation. So I'm with your strategy there. This time, it's possibly looking to see if there's any cheese left.
So now that we have actually already sorted out the first cheese in the basket, Gemini is going to know that there aren't any more cheeses left, and after it sorts these remaining 2 cheese in the grabber, I believe it will actually come back for the remaining Mars rocks.
Well, I was just wondering because it may not have known that that was a cheese that it dropped off, because it dropped it off in the moon rock
yes, that's
bin.
true.
So it's possible that it thinks there's still a cheese there. But definitely seeing some motion now, so perhaps deciding to move on and do what has to be done with these 2 lumps of green cheese. We're hoping to see it come over closer to us here in the commentary booth, which I believe is the correct location for green cheese. Diver is pointing directly towards us, so that's a good sign.
And it's making its move.
A question that I asked before of Florida, is there a feedback mechanism to determine whether it has something in the gripper or not?
It's also a no for us, and it's probably just because it's the same challenges we face in Florida, and that these connect pieces are very different in terms of nature from the previous hydrophones elements. Previous years it was the solid PVC pipes, which are much thicker and also a lot heavier. This time, just because it's so thin and small, it's very hard to actually detect mechanically whether we required it.
There's a tilt and a drop. Green cheese in the basket. And again,
And 2 cheeses.
beautiful. 2 cheeses. 2 moon rocks left on the platform. Let's see if it'll go back and go for a clean sweep.
That's what we're hoping for.
And even though there's no feedback on whether something's in the gripper, clearly it knew whether it had attempted with the 3rd gripper,
That is
because it
correct.
didn't bother to try to unload the 3rd gripper. This is just really a fantastic thing to watch here, because you just have to keep reminding yourself that there isn't any human control here, that this robot's really doing it all by itself, because it's doing such a fantastic job of it.
Back at our school university pool, usually it's been the 3rd time we come back for Mars rocks or cheese where we were able to complete it, just because when we're testing it at the university pool, we would say our success rate is maybe 60% in terms of the grab. And just because we have 3 grabbers and 6 elements to grab.
There was the grab, and there's a snatch. Yes. I'm sorry to interrupt you. That's a successful moon rock pickup. 1 more left on that platform. You know, I just really have a sense, looking at this, how much that moon rock weighs, and just really hoping that it stays in the gripper.
I'm also going to keep holding my breath until we actually go over to the baskets, because there's also a slight chance we might drop it again.
Positioning now on that one, attacking it with the side gripper. There's the pincers, not fully connected, but it's got it. I think maybe it grabbed it from both sides. That camera switch.
That's a firm grab.
There we go, still dangling there. Let's just hope it sticks. Going to be moving to the far octagon now, assuming all is well, to drop off moon rocks in that particular octagon basket. Perhaps a little survey there just to make sure that the pickup zone is empty.
We actually want to make sure that we aren't missing any points, just because each element in the hydrophone task can potentially be up to 4,000 points. So we don't want to make anyone unhappy by finishing our run and having potentially 4,000 or 8,000 points still in our plates.
Don't want to leave any on the table.
Right. So I think we're actually going to do it a little bit of an overkill and just make really 100% sure that we're done here before we check off the list here.
Well, still some time left on the clock. think it's safe to say that even if things went pear-shaped now, there wouldn't be another run. This has been a fantastic run so far. Now we're moving over to that octagon. I can see the diver pointing away from me. That is the correct octagon for these cubic moon rock blocks. And we'll see it now approaching that basket.
I can't help but wonder, Zaz, if Gemini's not smart enough to figure out that first piece of cheese had gone bad and maybe as hard as a rock.
Certainly possible. There's a rock in the box,
Yes,
and another one.
that's
Clean sweep
Nicely
of
done.
the pickup zone. Fantastic effort. Totally amazing. 10.5 minutes left on the clock, and so we could see now some attempts at some of the vision-guided tasks.
Right, so I think this is actually, I might have to scratch out what I said before. I think we're going to do now the thorough searching of the plate to just make sure nothing's there.
Just a little bit of a safety run, make sure all of those points have been swept up. There's a lot of jubilation there over the dock. I can hear them laughing from here. That team must be extremely happy with how this
Right.
finals run is going.
And also, to be honest, I haven't seen a complete autonomous run untethered at Transdeck where we have 6 successful grabs. So I don't know exactly what Gemini is going to do, but I think maybe it might, throw a little bit of celebration, make some go in circles, make a thorough search, and then we'll kind of let it do what it does.
All right. Well, this is exactly what you would want to see from a finals run. The best run so far of the week. Look at that empty recovery zone. Just exactly what you would want to see.
Feeling a little bit full myself just by seeing that empty plate.
Well, I've still got my heart set on seeing this rerouting power task take place. So I'm still holding out hope that we'll use this remaining 9 minutes to do a few other things.
There
There
we
we
go. I
go.
think
There's the victory swivel, right?
I think so. I think that's approval from our software, seeing that everything is going to plan. And then I believe, yes, the Gemini is making its way to the bins.
While it moves over, I don't know if we have time for one quick selfie. This is a Cornell fan that I've got up on the screen here, Luke. He's wearing his Cornell Pride shirt. Is he a former team member?
No, he's from FSAE. He's right next to us in the project team lab in ELL, and he's a good friend and also an amazing support.
All right. Well, it's that's super great that he's out there watching this on the webcast, and
Yes, we're awfully close to the bins.
there you can see those marker bins in their new arrangement this year. This new kind of circular or multi-angle arrangement instead of the standard identical grid, and a potentially confusing dark space in the middle as well. So there's a lot for a robot to deal with over there. We seem like we might have a bump into the wall there.
Yeah, I think we did overshoot it. I think as of right now, Gemini thinks that this is where the bins approximately should be, and that's why you can see it's doing a little bit of search sway to sway. I think it's going to make like a little bit of box pattern search.
Okay.
And in the case that it doesn't find what it's looking for, in this case, which would be the bins, I think it will time out or burst a lot of air and drop markers. See, Jaws, I don't know what it's going to do. Everything's optimized. Gemini's making its own decision. I'm here just to admire it.
No problem at all. No problem at all. We just appreciate the insight into what you think might be going on, having had more experience with the robot. But certainly we do not mind speculating up here on the podium.
And just because the way... Oh.
Up near the surface for a good view, but I have not seen a breach, so this run is still going. 7 minutes left on the clock.
It's surfacing down. I think
Diver, I think
it
said...
actually-
Well, it's in the vicinity of the
Descending.
boxes,
Mm-hmm.
or the bins.
Nice close-up here of that really sleek new design that you guys came up with this year.
And I think just because we were searching for the bins, but we couldn't find it. So I think what Gemini did was, it's just, I can't find it, but I'm just going to drop markers just because I feel like it. And now it's making its optimized decision of going to the power routing.
All right,
So-
that's what I've been wanting to see. This is the task once more that we involves moving pegs around on a vertical board. These pegs are magnetically attached, and we've actually had a question come in asking why hasn't any team attempted the power panel task. So at last, you, this particular viewer, will be satisfied as well, we hope. We can see there on the front of the sub the funnel attachment that slurps in those little power pegs.
That's actually exactly what Gemini is going to attempt to do. If you see in the very front of the vehicle, it does have a cone, a little bit like a mouth, and then it will be sucking in the cones using a high friction rubber, using also high friction rubber tape as well. And ideally, we'll be able to locate one of the pegs and then suck it in, zoom in on the available position and spit it back out.
Now this is a great shot to illustrate the difficulties of doing color underwater, because those blue spots just look like holes in the board, but they are not holes in the board, they're blue colored spots.
No. I guess Gemini's not feeling power outing today.
Well, I mean...
well, we can respect that decision, although it makes me a little upset.
Yes, I feel a little tantalized here as well. I was really hoping to see that task get attempted. Who knows what might
yes, I do want to emphasize the optimized mission run here, just because the way it is actually running is that Gemini actively determines its current location and its surrounding respective elements, and it knows the distance and also the success rates of all these potential tasks that we're going to do. So given all those data inputs, it makes a decision which is more optimal, which can give us more points in the future. And then depending on what things we haven't done or have done, it will ram into a torpedo bin.
We've got a collision with the UFO
I don't think
invitation.
That's not the most optimal.
Is that optimized? Yes.
And I think it's safe to say we might fire a torpedo at some point in the future.
Well, here's another example of how tough vision is in this environment, because that green background, again, against that wall, very, very tough to spot. So it's been hard for teams to dial in that torpedo task.
Yes, this torpedo task is actually not fully tested or tested in Transect at all, just because we had so much difficulty with the...
and go
It's
ahead.
up.
There's a breach. That's a run in. 3.5 minutes to go. The sub has decided enough is enough. Let's get back to the dock and total up those points. I'm sorry, what were you?
So that torpedo task was actually, we did decide to not go for it just because we had so much difficulty with the with the algae and also the background Transect. The green torpedo task is almost impossible and invisible. So at one point we did say let's not do it. But one of our software members, Chris, he was brave enough to say, you know what, let's go for it. We might as well try something with that remaining time, and that's exactly what happened today. And I'm pretty sure he was feeling a little bit happy to see his code that he written overnight to see in action.
Very nice. Well, we were inviting those aliens to brunch, and obviously the sub decided that sending a message wasn't enough, and kissing the UFO was what had to happen. So. It's great to see that kind of love being exhibited there under the water. Quick selfie shot here. We've got some Cornell supporters here watching the webcast. They've taken a great photo of themselves sitting there, tensely watching the run, appreciating everything that they have to see there. So great to see that kind of support out there. That is an official end of run. You must be absolutely thrilled with that, Mark.
Yeah, just because so many things were actually going wrong this summer, and also within the past week. For example, like one of the biggest troubles that we had to deal with was the flooding of the valve enclosure. Every time we'd fire a grabber, for some reason, our valve enclosure would flood, and that would cause all sorts of problems, such as coupling of the grabbers, sinking of the sub, and all of these headaches. So what we actually tried to do was, 3 to 4 days ago, we said, hey, if we can't keep the water out from coming to our dry enclosure, we're going to actively fill it with oil. And that's actually what's in our vehicle right now. And the simple logic behind that was, oil is minimally conductive and it does a good job of repelling water. So we said that's what we're going to do, and it worked out well for us.
Great. Well, I'm just super impressed with that run. It's just really amazing, and I'm really excited to see what Amy has got for us over on the dock with the team.
All right, everyone, I'm here with Marcus from the team Cornell, and we saw a beautiful run by their RoboSub. They only had to take one run because they did so amazing. We saw some awesome maneuverability through the gate, right at the buoy. Beautiful maneuverability around that maneuvering post. You got all the objects in the bins, and we even saw some interesting decision-making by your sub. Definitely the sub with the most personality so far. Tell me, how do you feel about that run overall?
I think it was an absolutely great run. It was one of our best runs here this summer, and I thought it went really well.
Awesome. I do know that during practice you had some issues with dropping objects as well. What did you do to change that between practice and the finals?
Really, we just made sure that our grabbers were all set properly, that there were no gaps in between any of the actual arms on the grabbers, and that all our offsets for picking them up were tuned properly so that we would grab them, as best as we could, and then be able to transport them also without, ideally dropping them.
Awesome. So we did see that the robot would tilt when it's trying to use a grabber on either side of the RoboSub. Was that a new thing that you added, or was that something there all along?
So that was something that we added maybe 3 or 4 weeks ago when we started working on the recovery task. And the idea for that was both to make sure we didn't crush any of the connects, or none of the connects got in the way when we would come to pick them up, as well as speeding up the actual dropping process when we're dropping them off. And so that was just us also trying to take advantage of our added degree of freedom in our controller.
All right, well, you're as cool as a cucumber. Tell me, how excited are you really?
I'm pretty happy.
Awesome, we're excited for you. Let's all give a shout out to Cornell. How well did they do, man? Awesome, right? All right, and who do you want to shout out to?
I'd just like to thank everyone else on the team, especially those who stayed here in Ithaca this summer, and those who have had the pleasure of staying previous summers as well in preparation for RoboSub. I'd like to thank all of our alumni, family, friends, everyone else at Cornell, as well as our sponsors. So thank you very much, guys. I really appreciate the help.
Awesome. Well, great job, Cornell. We're happy you're here, and what an amazing run here at RoboSub. Back to you, Zaz.
Thank you, Amy. That's just absolutely fabulous. Such a happy team. All of their hard work just really paying off with a fabulous finals run. Mark, thank you for joining us.
It was our pleasure.
You should be absolutely thrilled as well, and justifiably proud of your contributions to the team.
I think I'm going to go back, hug all my teammates, and also hug all the alumni. Just because, as Marcus said, we couldn't have done this without our alumni's help, because they've been the people who've actually made everything possible.
Any other virtual hugs you'd like to extend out to the viewers at large?
My family back home. No, but also the Cornell staff and university. They're very generous to us in terms of using the pool and all this faculty help in terms of the machine shop, all that. And especially a special shout out to our project team's director, Rebecca. She's here supporting us, and Professor Zender as well. So thank you.
Very good.
I think probably the only person who's just a little bit not so pleased to see that is Dave Novick, who's now going to have a bunch of work ahead of him making new challenges for next year, because that just made it look too easy.
Yeah, we'll see how that works.
All right. Thanks again, Mark. It's been fabulous having you up here. Great information. You should go back and celebrate with the rest of the team. You guys have really earned
All
it.
the hugs.
Yeah, congratulations to Cornell. Once again, very impressive.
All right, thank you very much.
Coming up next, Team Bumblebee from Singapore, the National University of Singapore. It's just fantastic to have them up here again. Let's cue their team video to get an introduction to that team.